right. You have reached Module 3, Level 3 of our Week 3 learning. It's like a video game in itself. Thank you for your patience as we've switched modalities and flexibility and understanding. I feel that's just the way things have been always, but in particular the last 2 weeks. I'm creating this video to kind of give you a sense of what is in the Week 3 folder. And the third module is allowing you time to explore these standards and really gain an understanding of them, as well as kind of dive into your particular grade ones. And I'll talk more about that task later. Instead, right now, I want to explain each of these different links right here. So the first one, a framework for K12 Science Ed. This document was referenced in the Module 1 with John Olson speaking. This is a book that really lays the foundation for understanding both the NGSS standards as well as the Minnesota State standards, the new ones. If you're missing out and understanding different pieces of the practices, cross-cutting concepts, and core ideas, this is your book. This is where you go. This is where you jam into things. It really dives into each of those different elements, as well as providing examples, definitions, all of the things. It's not necessarily a book that I'd recommend for you to purchase or even print out at this time. This is typically a book, actually it's not even typically a book, it is a book that districts use when they are integrating their science standards. It's a book that I had in Robbinsdale, provided to me from the district, as well as a book that Edina provided to me too. As you can see, each part has a different focus. And so this is laying out an understanding of what it is, all of the different pieces. Our guiding assumptions and organization, a deeper understanding of what the fractions are, or divisions are of the framework. So as we dive deeper into our work this semester, I'm going to be assigning different readings from this. Obviously not all 401 pages, but rather blips and blobs for you to really understand and have a foundation of understanding, not only to prepare you for your upcoming EdTPA testing and practicing, but also your future as a science teacher. So that is that first document. I'm going to close this. And when we go back into week 3, I want you to notice the differences between these right here. 2009 Minnesota Academic Science Standards. These are the standards that we are currently operating from. 2019 academic standards, these were created 3 years ago. It's hard to believe it's been 3 years ago already. Unfortunately, though, because of COVID, we have pushed back the full implementation of these. What's interesting with these science standards is that this is the first time that the Department of Education, for any content area, is adopting a 5-year implementation process, meaning that they don't need to, schools do not need to adapt them immediately to fidelity. Rather, it provides a timeline for a gradual shift, an opportunity to figure out where gaps are from previous standards to new standards, and so on. The adoption timeline has changed a little bit, as you learned in the first module with John Olson, due to COVID. What I'd like you to do is I'd like you just to spend some time in these old standards. Oh, it's hard for me to say old standards because I really want to say old/current standards, because these are still the ones that we're looking at and talking about. In Module 2, I shared with you that we have each of our 3 core content areas, and this was the model that was really kind of groundbreaking, I want to say. The National Giant, good grief, Next Generation Science Standards, NGSS Science Standards, again, were adopted in 2011. Of course, there were many conversations and such that led to them. Minnesota was a big stakeholder in those conversations. But ironically enough, we decided not to adopt the next generation science standards. Instead, we felt that our math standards were relatively new, and we felt that those were really awesome. Minnesota was not an adopter of the Common Core math standards. We felt that Minnesota's were more rigorous, and that also played into our decision of why we didn't adopt the next generation science standards for Minnesota. Instead, what was created was this graphic here, where we have our physical science standards, our earth and space science standards, and our life science standards. The nature of science and engineering was to have been embedded throughout, and so hence this beautiful little graphic here. What was discovered, though, was that people were teaching engineering and nature of science and engineering as a fourth standalone content area. And so hence the change for the 2019 science standards. Every time you look at standards, I did share the full document, and so there's a lot of meat and potatoes in here. I do encourage you to spend some time reading this work right here. I want to explain to you what this is. When you look at standards, standards aren't about, standards are our bottom line. A standard, regardless of the content, is the minimum expectation for a child at a particular grade level to meet. When you look at the science standards, you'll see that there are 4 strands. That's the case for math too. There are 4 strands. Within each of the strands for science are a number of different substrands, sometimes 3, sometimes 4. If I look particularly at earth science, there's 3 substrands. One is earth structure and processes. Substrand 2 is interdependence within the earth system. Substrand 3 is the universe, and substrand 4 is human interactions with earth systems. Within each of these substrands, then, are the standards required for learning. A little bit different than the 2019 standards is that these standards, while they look at it as a K12 thing, they're a lot more detailed. And while they look at it as a K12 progression, these standards are a lot more detailed and are it's like if you're walking along a path and there's a part of the sidewalk missing and you have to take a big jump. That's kind of how these standards are. For example, in life science, ecosystems is addressed in kindergarten, a little in 1st grade, and then in 5th grade. So we have a big jump from from 1st to 5th grade. So those new standards, we'll look at them, they really help us to understand and lay a stronger foundation. This page in particular is really laying the foundation of understanding what the science standards are and how to read them. Right here, each standard has a numbering right here. The 3 references 3rd grade. The number 1 is looking at the 1st strand, the nature of science and engineering. This number 1 right here is the 1st substrand, which is the practice of science. And I can go back right here to the numbering to understand. 1, 1. Then the next one is the substrand, then we have the standard. So within each standard are specific benchmarks. Consider the standard as your learning target. The benchmark is your nitty-gritty of how you're going to meet that standard. So in 3rd grade, under the nature of science and engineering, the practice of science, the standard of scientific inquiry is a set of interrelated processes incorporating multiple approaches that are used to pose questions about the natural world and investigate phenomena. That standard is met by making sure that our students are able to do these 4 benchmarks. So when I look at the standards, the 2009 standards, you can see that it starts in kindergarten. Kindergarten has 1 standard with the substrand of the practice of science, 1 substrand with the practice of engineering. As we scroll through, you can see there's only 1 physical science standard, a couple of earth science, and a few life science. as we go into first grade and moving through and continuing, what you will notice is that most of the grade levels have this first one right here, the practice of science, focusing on scientific inquiry, as well as the practice of engineering. Engineering design is the process. What you'll start to notice is that the engineering standards, though, are really only in second grade and fourth grade. The physical science standards are really only in second grade and a little bit in fourth grade. What I want you to do with these standards here is I want you to find the grade level that you are currently working with. And I want you to take time to read them. So if I was in a third grade classroom, I'm going to start right here where this 3 is, and I'm going to take time to understand these are the standards, these how the standards are being met. What you can do also is you can go back to see what are my students coming into third grade with. So I look right here. This is third grade, strand 1, substrand 1, standard 1, benchmark 1. I want you to see if you can find this code in second grade. So in second grade, it would be 2111. So I'm going to scroll up. Nope. No 2111, but there's a 2112. And that 2 right there is for the second standard. And so that's my indicator as a third grade teacher that my students actually haven't had that standard since first grade. So the benchmark that they have in first grade is when asked, how do you know? Students support their answer with observations. For example, use observations to tell why a squirrel is living. So I go up to third grade then, my third grade standard of 3111. And you can see how that first grade standard lays the foundation for this standard, this benchmark. Provide evidence to support claims other than saying everyone knows that or I just know, and question such reasons when given by others. So what I'd like you to do is take time, look through these 2009 science standards to gain some understanding, look forward at where your kids are heading, and look backwards to see where they should be coming from. I'm going to pause this video and then create a second one to explain the 2019 standards.